Alright, so I'm continuing work on my control panel for the solar array, and I was thinking that I've got 16 pins here for temperature sensors. So 16 temperature sensors are going to draw 16 times the current. So I'm going to need a external 5-volt source. I'm just not going to draw that much current through the Arduino. So I found a, where is it? Just a 5-volt voltage regulator. It's pretty common. You can find them in things like this is just a regular old circuit board with a 5-volt regulator on it. And this is another one. It's a big power supply. It's got a 6-volt regulator on it. So those are just the pre-built ones. So I've been building one here. I went through piles and piles of scraps and I couldn't find the right one. And so this is an opamp based voltage regulator. Let me see if I can get the drawing to show up there. The light will change. There it is. So pretty basic. Just one transistor, NPN transistor, and then this is your output right here. And there's lots of drawings for these online. That's just a very simple one. Now the cool thing about this homemade voltage regulator, well, besides making it, which is fun, this little guy on idle consumes about 5 or 6 milliamps. Let's see if I unplug here, turn off the Arduino. This guy, the homemade one, idles at 1 milliamp. So when you make your own stuff, it takes up a little bit more room, but usually works a little better. Okay, so I've got the circuit just loosely put onto this little prototyping board, and I wanted to go over a little bit about how I go through this process. Now, first thing I do, obviously, I just start playing around with the parts and sticking them in and making some light drawings of things. Here, I'll get a better view of this. And the way all the parts line up and things, and making sure I've got my circuit drawing out right next to me with all the components and everything all listed, so I can double check that, don't make any mistakes. And then as soon as I've got the layout for the circuit basically how I want it, then I flip the page over, trace out all the pins where they come through on the prototyping board, and then draw all my traces. So I use graph paper, so each square is actually one hole, and that's really helpful, because now when I want to actually solder, I just flip this over and that's the actual design. Right, I don't have to do any reversing in my head because there's always a mistake. It's usually late night. So this is just a really handy technique to get you that map. Alright, so a little while later, and I've got the circuit working on the prototype board there. And I just wanted to show this. This is the voltage coming out of the circuit now, powering the Arduino. This is the current coming from a 12-volt battery powering the circuit. So losing about 5 volts into there. And if I check the input voltage now, I'll add another 6-volt battery. So we have 18 volts input. And so I'll have pretty much the same voltage there. So 7.16, and then I'll go back down to 12. 7.13, so 3/100ths of a volt, 3 millivolts difference for 6 volts difference. Cheers. Alright, so I'm outside and I've got the voltage regulator section of the new control panel hooked up, and I wanted to talk about why I rushed this section out. And basically I wanted to turn off this inverter throughout the night. It was pulling a ton of current, and the batteries aren't really built for that. They're not deep cell batteries, so anyways, I wanted to run the Arduino off of the battery pack directly instead of running through multiple transformers and stuff. So when the battery pack gets up to about 14 volts, which it has been lately, this poor little voltage regulator, and I'll show you exactly what was doing all the heavy lifting before, is this poor little guy right there. That little black guy, that was doing everything, converting the 14 volts down to 5 volts that the Arduino uses. And I came home after a day of sun and burnt my finger on that poor little thing. So now this whole regulator circuit is working. that big heat sink is now sinking all of that heat instead of that poor little guy, and it's staying ambient. Yesterday, I actually watched the battery pack get up to about 14.4 on the controller side. The battery side was still about 14.1, so there is still a voltage drop issue even with these thick cables. Under load, there is still a voltage difference. When there's no current flowing, the voltage is pretty much exactly the same. So just a little bit of a weird thing there.